Welcome to Garden Bound and our exploration of aquaponics. Today, we will delve into the multiple benefits of integrating aquaponics into your gardening practices, and take you through the process of setting up your own aquaponic system. This system not only conserves water and eliminates the need for chemical inputs, but also allows you to grow fresh, organic produce right in your backyard, or even inside your home. If you're interested in learning more about gardening, don't forget to hit the notification bell and subscribe. Don't forget to leave any tips and tricks you've learned along the way in the comments. Let's get started. Aquaponics combines aquaculture, the raising of aquatic animals like fish, with hydroponics, the technique of growing plants without soil. This system utilizes the waste produced by the fish as a nutrient source for plants, which in return purify the water that goes back to the fish tanks. This cyclical, symbiotic system offers a sustainable model for food production, applicable in various environments from urban rooftops to rural setups. The core of an aquaponic system is the cyclical water flow that emulates natural ecological processes. Fish produce waste, which contains ammonia, toxic in high levels. Beneficial bacteria in the biofilter convert this ammonia into nitrites and then into nitrates, nutrients vital for plant growth, yet harmless to fish in moderate concentrations. The water, enriched with nitrates, is then circulated to the grow beds, where plants, rooted in inert mediums like clay pellets or gravel, absorb the nutrients. This filters and cleans the water, which is then recirculated back to the fish tank. This efficient system conserves up to 90% more water than traditional gardening by recirculating water instead of losing it through soil absorption or evaporation. Aquaponics also reduces the need for chemical fertilizers and pesticides by leveraging natural fish waste, which bacteria convert into a rich, organic nutrient source for plants. This cycle not only supports plant growth without synthetic chemicals, but also produces safer, healthier food. Moreover, aquaponics systems require minimal land and can be set up vertically in small or unconventional spaces, enhancing food production in urban areas and reducing the ecological footprint of agriculture. Aquaponics systems are renowned for their ability to produce faster growing plants and higher yields when compared to traditional gardening methods. Research has shown that plants grown in aquaponic systems can mature up to 25% faster and produce 30% more yield on average. For example, a study highlighted in the Journal of Soil and Water Conservation found that lettuce in aquaponic systems grew to harvest size in just 29 days, compared to 45 days in traditional soil cultivation. This accelerated growth rate is attributed to the direct access to nutrient-rich water, which reduces the energy plants typically expend in root expansion to search for nutrients, allowing them to focus more on growing upwards and producing biomass. Additionally, the controlled environment of an aquaponic system minimizes the stress factors often associated with soil gardening, such as pests and fluctuating soil conditions, further enhancing growth efficiency and productivity. These characteristics make aquaponics an efficient, productive, and sustainable method for cultivating plants, providing ample opportunities for both commercial producers and home gardeners to achieve better results in plant growth and yield. Want to set up your own system? In this next section, we are going to cover the how of setting up your own aquaponic system. Choosing the right location is crucial for setting up an aquaponic system, especially for beginners. You must decide whether to set up your system indoors or outdoors, each option coming with its own requirements and benefits. Indoor systems are protected from the elements, allowing for year-round operation regardless of external weather conditions. These systems require artificial lighting to support plant growth, but offer better control over temperature and environment. Ideal locations for indoor systems include basements, garages, or even spare rooms where temperatures and lighting can be controlled. Outdoor systems, on the other hand, utilize natural sunlight, which is beneficial for plant growth and can reduce operational costs. However, outdoor systems are subject to seasonal changes and weather conditions, which can affect their productivity. It's essential to choose a spot that receives sufficient sunlight, at least 6-8 hours per day, and is protected from extreme weather conditions like strong winds or heavy rains. The system should be placed in a location that matches the temperature requirements of the fish and plants you intend to grow. The size of your aquaponic system will depend on the available space you have and the amount of produce you aim to grow. Small systems are suitable for personal use or hobbyists and can be set up in small spaces like balconies or small backyards. A small system can consist of a single fish tank, about 50-200 gallons, and 1 or 2 grow beds. This size is perfect for growing leafy greens and herbs, and for raising a small number of fish, such as goldfish or bettas. If you have more space or want to produce a larger yield, consider a system that includes multiple large tanks and several grow beds. These systems are ideal for producing significant amounts of vegetables and fish year-round, suitable for larger families or commercial purposes. Ensure your space can accommodate expanded tanks and additional equipment like larger pumps and more complex plumbing. The basic materials needed for an aquaponics system include fish tanks, grow beds, piping, pumps, and other necessary equipment. Choose durable, non-toxic containers for the fish tanks that can hold water without leaking. Popular options include polyethylene tanks, IBC totes, or large barrels. The size of the tank will determine the amount of fish you can sustainably raise. Grow beds should be made of safe, water-resistant materials and can be filled with a soilless growing medium such as expanded clay pebbles or gravel. The depth of grow beds typically ranges from 12 to 16 inches to accommodate most plant root systems and ensure effective water filtration. PVC or other safe plastic piping is used to connect the fish tanks to the grow beds, and you should include all necessary fittings such as valves and adapters to manage the water flow. A reliable water pump is essential for circulating water between the fish tank and grow beds, and you should choose a pump with an adequate flow rate to ensure the entire water volume circulates multiple times per hour. Water heaters may be needed, especially in cooler climates, to maintain optimal water temperatures for fish. Testing kits and monitoring systems are essential for maintaining water quality, pH, and nutrient levels. Regular testing and monitoring will help ensure the health of both fish and plants. Depending on the complexity and size of your system, you may also need air pumps for oxygenation, biofilters for additional filtration, and grow lights for indoor setups. Setting up the fish tank is the first critical step in assembling your aquaponics system. Begin by choosing a level, stable location for your tank, as this will ensure consistent water levels and prevent undue stress on the tank structure. Indoor locations typically provide more environmental control, reducing temperature fluctuations and protecting the tank from extreme weather conditions. Outdoor setups require careful consideration of shade and sun exposure to maintain suitable water temperatures for the fish. Once you have identified the perfect spot, place a sturdy stand or platform to support the tank's weight when filled with water. This platform should be level to prevent uneven water distribution, which can impact the efficiency of your system. After positioning the tank, rinse it thoroughly with clean water to remove any residues or contaminants. Avoid using any chemicals or soaps during this process. Next, fill the tank with dechlorinated water, as chlorine can harm your aquaponics system's fish and beneficial bacteria. If you're setting up the tank outdoors, consider adding a cover or net to prevent debris from entering the tank and to protect the fish from predators. The next step is to construct the grow bed where your plants will thrive. Choose a location for your grow bed that is close enough to the fish tank to allow easy circulation of water. The grow bed should be elevated above the tank so gravity can assist in returning water to the fish after it has passed through the grow bed. You can use various materials for grow beds, such as large containers, custom-built boxes, or commercially available hydroponic beds. Ensure the material is durable, non-toxic, and capable of holding the grow medium and plant weight. Commonly used grow mediums include expanded clay pellets, gravel, or lava rocks, which are lightweight, pH neutral, and provide good support and aeration for plant roots. Fill the grow bed with your chosen medium, rinsing it first to remove dust and particles. The depth of the grow bed should be at least 12 inches to accommodate most plant root systems and facilitate effective filtration of the water. Set up a drainage system at the bottom of the grow bed to allow water to flow back into the fish tank. This can be accomplished with a simple drain or a more sophisticated bell siphon system that regulates the flooding and draining cycles automatically. Installing the water pump and plumbing is essential for maintaining effective water circulation between the fish tank and grow bed. Start by selecting a water pump that can circulate at least the total volume of your fish tank every hour. This ensures optimal water quality and nutrient distribution. Place the pump inside the fish tank, securely attaching it to the bottom to prevent vibrations and noise. Use durable, non-toxic tubing or PVC piping to connect the pump to the grow bed. The pipe should be wide enough to handle the flow rate without causing restrictions or back pressure, which could damage the pump. Run the tubing from the pump outlet up to the grow bed, ensuring it is securely attached and leak-free. Use pipe clips or ties to secure the tubing along the route to prevent sagging or kinking. At the grow bed, the water should be distributed evenly to reach all plants effectively. This can be achieved by using a spreader bar, drip lines, or a simple perforated pipe that disperses water across the grow medium. After connecting the tubing, test the system by running the pump and observing the water flow through all components. Make adjustments as necessary to achieve uniform water distribution and ensure that the water freely returns to the fish tank. This step is crucial in setting up an efficient aquaponic system that will support healthy plant and fish life. When adding fish to an aquaponic system, the choice of species is crucial, especially for beginners who may not be familiar with the specific care requirements of more sensitive fish. Suitable beginner fish include tilapia, goldfish, and catfish, known for their hardiness and adaptability to varying water conditions. These fish are also less prone to diseases and can tolerate slight fluctuations in water quality, which are common in newly set up systems. To acclimate fish to your aquaponics tank, begin by floating the sealed bag containing the fish in the tank water. This equalizes the temperature between the bag and the tank, preventing thermal shock. After about 15 to 30 minutes, gradually introduce small amounts of tank water into the bag every 5 minutes for an hour. This helps the fish get used to the water chemistry. Finally, gently release the fish into the tank using a net to avoid transferring bag water, which may contain impurities or pathogens. Choosing the right plants is just as important as selecting fish. Leafy greens like lettuce, kale, and Swiss chard are excellent choices for beginners due to their low maintenance and rapid growth rates. These plants thrive in aquaponic systems because they can efficiently uptake dissolved nutrients from the water. Herbs such as basil, mint, and watercress are also well suited as they require similar conditions and provide additional variety. Planting in aquaponic systems generally involves using a soilless medium such as expanded clay pellets or gravel, which supports the plants while allowing water to circulate through their roots. To plant, gently spread the roots and place them in the grow bed, ensuring the crown of the plant is above the medium to prevent rotting. It's important to space plants adequately to allow for air circulation and access to light, which reduces the risk of fungal diseases and promotes healthy growth. By carefully selecting and properly introducing fish and plants, you can ensure a balanced and productive aquaponic system that provides fresh produce and fish with minimal environmental impact. Maintaining an aquaponic system is essential to ensure its efficiency and productivity. Daily tasks include feeding the fish and monitoring their health and behavior for signs of stress or disease. It's also crucial to check water levels daily to compensate for any loss due to evaporation by adding fresh water. Weekly maintenance involves testing water parameters such as pH, ammonia, nitrites, and nitrates to ensure they remain within safe ranges for both fish and plants. Adjustments might be needed if any parameters are off, such as adding buffers to stabilize pH or adjusting feed rates to manage nutrient levels. Cleaning the filters to remove any solid waste and prevent clogging is also necessary to maintain water flow and aeration. Inspecting all equipment, including pumps, pipes, and aerators for proper function, and signs of wear or damage ensures that the system operates smoothly without unexpected interruptions. Several common issues can arise in an aquaponic system, including pH imbalances, problems with fish health, and plant nutrition deficiencies. The ideal pH range for most aquaponic systems is between 6.8 and 7.2. If the pH falls outside this range, it can affect the availability of nutrients to plants and the health of the fish. To raise the pH, limestone or calcium carbonate can be added. To lower it, phosphoric acid or a commercial pH down product can be used. Regular monitoring and gradual adjustments help maintain the balance without shocking the system. Poor fish health can be indicated by signs such as lethargy, not eating, or visible sores. Common causes include poor water quality, incorrect temperature, or overcrowding. Regularly checking and adjusting the water quality and temperature, maintaining good aeration, and ensuring appropriate stocking densities are critical for preventing health issues. If diseases are suspected, identify the specific ailment and treat with appropriate aquatic veterinary medicines. Signs such as yellowing leaves or stunted growth might indicate nutrient deficiencies. Since nutrients in an aquaponic system come from fish waste, inadequate feeding, or imbalanced fish-to-plant ratios can lead to deficiencies. Ensuring a balanced diet for the fish and adjusting the system's feeding rate can help. For immediate treatment, supplementing specific nutrients directly to the plants can correct deficiencies. Setting up and maintaining an aquaponic system offers a fascinating and sustainable way to grow your own food. By understanding the essentials of system setup, fish and plant selection, and routine maintenance, you can create a thriving aquaponic garden that benefits the environment and yields fresh, nutritious produce. Remember, the key to success lies in regular monitoring and maintenance, which ensures the health and productivity of both your plants and fish. With patience and dedication, your aquaponic system will not only provide a steady supply of food, but also bring a unique and rewarding experience right to your home or garden. Until next time, happy gardening.